Good morning, everyone, and welcome. I'm Bonnie Raindrop, Project Director for Pesticides in the Chesapeake Bay Watershed Project, a program of the Maryland Pesticide Education Network. I'm really delighted with the program we're bringing you today. It's timely and relevant. We have an internationally renowned expert in PFAS testing, Dr. Graham Peasley, our keynote. The issue of PFAS and pesticides opens very concerning questions, and Dr. Peasley will shed some light on tools we can use to tackle some of them. We're all here today as stakeholders in the ways pesticides impact the Chesapeake watershed. You may be a scientist or a representative of a government agency or work in public health. You might be an environmental or community advocate, a farmer, a beekeeper, or another kind of stakeholder. But concern about pesticides brings us here today to learn and share. It's an extraordinary group, and the project is an opportunity to learn and collaborate more effectively in addressing pesticide impacts. And thank you for taking the time to be here today. So let's get to it. Please open your chat, say hi, tell us who you are and what you're interested in. Let's use chat to comment and network today. Then open your Q&A tool and put your questions in during presentations. Speakers will answer live or in text. I'll send you the chat transcript of messages sent to everyone. You'll also receive the Q&A transcript, presentation links, and the conference attendee roster to help you network. Next. I want to turn things over to Dr. Greg Allen, our conference moderator and the project's Research and Data Gaps Working Group co-lead. Dr. Allen is an environmental scientist at the U.S. Environmental Protection Agency, Chesapeake Bay Program Office, and is approaching a 30-year anniversary at EPA. He's chair of the Chesapeake Bay Program's Toxic Contaminants Work Group and coordinator of the Partnering Leadership and Management Team. For nearly a decade before joining EPA, Greg was in the field and at the analytical chemistry bench analyzing the occurrence of organic contaminants. Greg counts among his most meaningful recognitions a White House Closing the Circle Award, an EPA Gold Medal, and a handwritten thank you note from the Puget Sound Partnership for helping with their PCB reduction strategy. Welcome, Greg.
Thank you so much, Bonnie. Good morning, everybody. So glad to have you here with us today, and we have a wonderful program for our couple hours together this morning. So we will, excuse me, we'll be hearing from some absolutely wonderful presenters today. I'm going to run through our agenda and our presenters. So we're going to start with Dr. Graham Peasley. He is at University of Notre Dame. And as Bonnie mentioned, we'll be talking a lot about PFAS and pesticide formulations. Then we will hear from our Research and Data Gaps work group, and they'll be featuring a report that we're almost ready to get out the door. We're putting the last touches on it, but we're going to give you a preview of that report. We'll hear from Vicki Blazer at USGS. Unfortunately, Ian Hartwell, recently retired from NOAA, is not with us today. He's working through a COVID diagnosis, so we wish him all the best and a speedy recovery. And I'll be helping out with that one as well. And then we'll hear from Kristen Harbison at the Maryland League of Conservation Voters, and she'll give us some insights about the results of the election in Maryland and what it might mean to some of the legislative groups that deal with environmental issues. And then, as is typical for us at the end of our annual conference, we will hear from our project working groups on a few of the key items that they are working on. And we're also going to revisit the Jamboard that we created last year. If you were with us last year, you'll remember we had a very large group Jamboard where we're asking for input, ideas on what were some important areas of work for this project and for our working groups. And we're going to let you know what we're doing with that information, a couple of next steps, and a way for you to stay involved with that if you'd like to. So that is the game plan for today. And before we jump in here, we want to remind ourselves about some of the things that have made this project so special and so unique and has sustained us for now 16 years. 16 years. So I'm going to pause for a moment so you can read this list of our shared values. And I think it's really the fact that we have lived these values out when we come together to have these sessions, along with the fact that we have work groups that produce meaningful products. Those two things really are the hallmarks of this project, and we are going to keep living that out. Today is going to be a great way for us to take next steps. So, all right. Well, with that as a bit of introduction, we can go ahead and hear from our keynote speaker, Dr. Graham Peasley. Dr. Peasley is a professor of physics at the University of Notre Dame. He leads an active research group that develops novel analytical methods to measure chemicals of concern in the environment. In his 35-year career, he has 231 peer-reviewed publications. It's really amazing, including 22 publications on the topic of measuring PFAS and their fate and transport in the environment. And he has one patent on a method for detecting fluorinated chemicals in liquid. He's also a co-author of the Madrid Statement on Poly and Perfluoroalkyl Substances, which is dedicated to the reduction in our non-essential use of these highly persistent and toxic chemicals. He earned his bachelor's degree in chemistry from Princeton University, as well as a PhD in chemical physics from the State University of New York. Dr. Peasley is also a fellow of the American Chemical Society. So we're so honored to have you with us today, and I'm going to hand this over to Graham.
Hello, my name is Graham Peasley, and I'd like to thank the organizers first for inviting me to speak today. I'm going to tell a quick story on PFAS and what they are, and how to measure them in the environment. I apologize for not being there in person. I'm abroad at the moment, but I'd like to be able to include pesticides in the environment and say why and how the PFAS are there, and then give some suggestions as to how to measure them. PFAS is a large class of organic chemicals called per- and polyfluorinated alkyl substances. Picture of one is shown here. They're developed in around World War II. They're all man-made, and they have a confusing array of names over the years. But since about 2012 or so, we've settled on this PFAS nomenclature. There's over 12,000 of them that are currently listed on the EPA website. They have amazing properties. They are surfactant. You can see the fellow on the right here treated with a PFAS outfit, and the guy on the left is not. They're used on carpets, textiles, paints, cosmetics, coatings, you name it. They're a type of lubricant or surfactant that's used everywhere. There's over 200 known industrial uses already, of over 1,300 PFAS, specific PFAS, out of the 12,000 that we know exist. Some of those are not commercially made. They're degradation products of the original ones, but they're all different types of PFAS. Some background chemistry just to get us all on the same page. is that they have this long chain of carbon and gray, with green is the fluorine in this particular style of looking at them. They have these long chains that are very water repellent, and then a head group, which is either a carbonate on top or a carboxylic acid on top, or a sulfonate on the bottom, or a sulforamine on the bottom. And these are different. It gives them different properties, but all of them have a wonderful surfactant property where this one end loves water and the other end likes air or something that oil, something that isn't water. And so they work well as a soap, but they also work extremely well as a surfactant layer to prevent water resistance or stain resistance. The reason they work so well is that there's a bond energy between that carbon and fluorine bond, which is the strongest bond in the chemistry periodic table. I mean, carbon and fluorine is the strongest single bond of all the atoms, and so it's the hardest to break. We have used them everywhere, from our non-stick cookware to carpets to a microwave popcorn. You can ask me about that later. While it prevents the water from inside the kernel getting the bag wet, the paper bag wet, it has some other consequences. What's the problem? Well, since the carbon-fluorine bond is so strong, they have environmental lifetimes in the hundreds or thousands of years. There's no known organism that will eat on these things because they don't get any energy out of eating them. There's one weird microbe that's been discovered that sort of chews on some of them, but it's only the large ones that break down to small ones. These small ones persist forever, and these are why they're given the moniker forever chemicals. One of the consequences of it is that these chemicals, once they're made, they don't degrade. They can pass right through the wastewater treatment plant and get into our drinking water. And the drinking water gets into us, or gets into our food, which then gets into us. And it can come from any number of sources. From firefighting foam is the largest one we think that's gotten out there, but it also comes from our landfills. Of all the materials that we've treated in the last 70 years that have come out of the landfill are starting to come out and will haunt us for the next hundreds of decades or centuries, till this stuff gets all the way through the water and through our bodies. In drinking water, we've got a map currently on the EWG working website, the Environmental Working Group website, that shows how many states are actually looking for PFAS, and you can count on one hand the ones that have done a good job so far, and then the rest of us that are slowly beginning to get there. It's not that there aren't any PFAS in Indiana, just nobody's looked for them yet. We're starting to. And the EPA has made a health advisory limit that we're at 70 parts per trillion, but startled everybody by going down 1,700-fold to 0.004 parts per trillion for PFOA and 0.02 parts per trillion for PFOS, and including a couple others that are a little higher levels. This is concerning because these are the concentrations at which you begin to see adverse health effects. And of course, those health effects don't just have to be humans, they could be in the environment. There's both bioaccumulation and biomagnification of these chemicals. Since they're so long, they live in the decades to centuries in the environment. That means that when we eat fish that have eaten the items that have been exposed to this, we'll pick up what's in the fish. The polar bear don't really eat a lot of popcorn, but they do eat seals that eat the fish that eat the krill that have been swimming through this waste AFFF for years, and therefore the polar bear blood has a fair amount. Human blood in North America consists of about 5 parts per billion of these man-made chemicals, and we see it in every person in North America at this point. And of course, there are the unfortunate adverse health effects that come with them, and everybody knows the C8 study because it was so famous. There's a movie about it, but it's this cancer cluster, and there are 6 diseases that are known to be correlated with this exposure to C8, which is one particular type of PFAS. And it led to the voluntary removal of this PFOA and PFOS from use for manufacture in the United States. They're still used, but not manufactured in the United States any longer. And the diseases, there are 2 types of cancer. There are kidney and testicular, hypertension and pregnancy-induced hypertension, preeclampsia, ulcerative colitis. And now, if we look in the literature, you'll see that there's a whole bunch of other diseases that are being discovered from the year 2000 to 2000 instead of a few studies a year. Last year we topped over 1,400 studies that, if you look up PFAS or PFC and health, you'll see over 1,400 papers published on this. So there's a scary amount being discovered. Probably the most insidious one is the immune system reduction. This is the reduction of the immune system of vaccines, for example, vaccine titer, if you've been exposed to these, observed in both Europe and in America. These and now elsewhere. This is the reason that the European Food Safety Commission reset the limits lower on the amount allowable in food. It was because that was the most sensitive effect that they found. The American standards were set on, I believe, a thyroid cancer or pancreatic cell cancer cell line that was so sensitive that they could lower the limits that much. So how are they measured? In general, they're measured by this wonderful instrument on the right called a liquid chromatography tandem mass spec. This is a sophisticated instrument, costs $250,000. They have run for 15 to 20 years now a standard method for drinking water the EPA's had out called 537.1 or a 533 method, slightly different number of analytes in that, but about between 20 to 32 analytes of these 12,000 compounds. And there's a new method out that's still draft stage, but is being used by commercial labs called EPA method 1633, designed specifically for sediment, sludge, and fish and biota, sort of nastier matrices than drinking water. This instrument has exquisite sensitivity. It'll identify P4 and tell it apart from PFAS, which the rest of us can barely do, looking at the pictures on the left. It needs lots of time and it's lengthy analysis, and it needs many standards. You need to have a standard of everything that you measure. And it misses all the volatiles that don't transport through the liquid, and it also misses all the precursor mass. And often the volatiles could be short chains, C2s and C3s, but there'll also be fluorotelmer alcohols and things like that evaporate before you get it in the system. So you don't get everything with this method, but what you do get, you get exquisite sensitivity down to part per trillion or less of some of these elements. And it identifies specifically which ones are there, which helps you identify perhaps the source. The caveat is that it only identifies what it's looking for, what's in the library. So let's look at pesticide for a second. If you were trying to measure these with an LC mass spec, yes, there are some pesticides made with PFAS, the most famous of which is sulfuramide, which is a mainstay in Brazil for the leafcutter ant. And it was an insecticide made out of PFAS. There is a picture of it. You see the long chain of fluorine and carbon in the left, and then a sulfonate group with an amide on it, which makes it a sulfuramide. That's the compound that is very effective at getting leafcutter ants out, but of course led to a tremendous toxicity problem in Brazil's Amazon basin. It's got a massive PFAS contamination. And of course, I looked online and I can buy 50-gallon drums of this stuff still from Wuhan Bright Chemical, another wonderful product out of Wuhan that we can buy. So these are still around and they exist. They may enter this country illegally. They're not supposed to be manufactured here, but it's not quite clear what the import-export regulations are. More likely is that some of these pesticides have additives that contain PFAS. And this would be if you're going to take an aerosolized PFAS, you might add a dispersant to it or a solubilizer. And those, the best ones available are the fluorinated ones, so somebody may have manufactured them with an extra agent. It wouldn't be the active ingredient, but there might be a few percent of these PFAS in as a dispersant or a solubilizer. That could be why a pesticide has PFAS in it. Then there are some pesticides that contain fluorine, but are not PFAS. And this gets into a technical definition. If you take a look at, for example, this one at the bottom, India just launched this last year, fluopyramine, I think I pronounced that right, is a new compound. And you'll see that there's a CF3 group attached to it. So if you measured fluorine, you would see this, but it's only one, and it would break off as a C1, and it wouldn't count as a PFAS by definition. Not that I'd want to drink this, but if it got into the drinking water, it probably wouldn't have the same effect as PFAS, just what the insecticide said, whatever the toxicity of the insecticide would be. The unfortunate part is that more and more pesticides are putting more fluorine in them. So almost 70% of the new agrochemicals approved in the second half of the last decade, this is published in 2020, included a fluorinated grouping in it. That doesn't mean they're PFAS, just that there's a little fluorine in them. So leaving these categories aside, we go back to what there are, there's another source of PFAS in these pesticides, which is a dazzling array of these things. There is a suspicion that a pesticide in Massachusetts recently was tested to found part per billion levels of 1,000 times more than a part per trillion. And those levels are very high if you were to release it into the environment. And they were found at that level because of the argument that the container leached these out into the pesticide. And from all we can tell, that might be one explanation. It may be that another explanation leads to PFAS being in there. But we've managed to reproduce the study that there are some chemically resistant containers that are fluorinated, and they create PFAS, and when you put certain things in them, you'll get PFAS out. And that would be one where the insecticide did not have PFAS originally, but after it got stored in this container for a month or two, it's loaded with PFAS, and therefore would not be good to get out in the environment. And then, of course, there's the last category, which we're all very interested in, which are the pesticides that don't contain PFAS and won't have any other additional sources added to them. This leaching result came out recently in September of 2022. They studied that there are surrogates you could put into these containers and leach out. When it comes to measuring fluorine overall, what should we do? So there's our LC mass spec. That's the red thing in the middle, and this is sort of a Venn diagram approach to it. That you can target certain PFAS, look for P4, look for PFOS, look for PFHXS or PFBA, and all these various chemicals that are of concern to the EPA, you can look for them and you'll find them down to part per trillion levels. If they're in your insecticide, you probably wouldn't want to be dispersing that, not only for the insecticide reaching the environment, but for, even if the insecticide broke down in the environment, biocompatible insecticide, these PFAS would pass right through and get into biota and the environment. There are several other types of methods by which you can measure more fluorine, and so what we're going to describe now is a couple of total organofluorine measurements, and I'm going to specifically talk about ours that we developed at Notre Dame, Piggy, to get the total fluorine measurement and why you want to do that. So this is a spectroscopic tool to look for just the fluorine part of the molecule. And if it's a PFAS, it's got lots of fluorine. And so therefore, wouldn't it be interesting if instead of doing the long study, we could just take a light source, shine it on a sample, and measure with a detector, sort of like they do with X-ray fluorescence to measure lead in toys coming from China. We would take an available light source, put it on a sample, and tell you instantly whether there's any fluorine in there. And that fluorine we'd use as a surrogate for PFAS. And unfortunately, there's no light sources of the regular type UV-Vis or for FTIR, infrared spectroscopy, or NMR, or even XRF that will give you a fluorine signature that you can use. It's not sensitive enough in a couple of these cases. There are no transitions in others. And the FTIR, there's some sensitivity, but there's lots of different things that give the same signature. So what we've used is a gamma ray signal. And using that, we move into this type of instrument. It's a large particle accelerator at the moment. We're making a smaller one for a field application. And we bombard a surface and look for the gamma rays that come off. And we can use this to make a spectrum that looks like that. It shows clearly a popcorn bag versus regular paper. And you could see right away which one had been treated by PFAS. We've also used it for, and we published a paper in 2017 on fast food packaging, which has encouraged the industry since that time to remove PFAS from all their packaging. In 2020, we followed it up with a study on Firefighter Textiles. Not only were they being exposed to AFFF, the firefighting foam that has PFAS, but their turnout gear turned out to be made with PFAS, and that was alarming. In recent years, the last year, we published an article on cosmetics and our personal care products that seem to have a lot of PFAS in them as well. And we point out that you could get direct exposure through the skin or through the accidental ingestion, as well as going through the drinking water that everybody will be exposed to. And that one was also widely read. So what I would like to leave the audience with is this idea that we have a complex chemical mixture in insecticides. There's always a lot of ingredients in there. My proposal would be that you should screen pesticides for the presence of total organofluorine. There are several commercial methods to do this. We've just got one, but there are other ways that can also measure total organofluorine. And if there's no fluorine, then you have a pesticide that has no PFAS in it because there's no fluorine. And that's the trick. Then these tests are typically a lot cheaper and quicker then the test where you'd send it off to a lab, wait 6 weeks and find out, yep, there's this many parts per trillion of this, that, the other. If you get a measure of fluorine that's 0 or below detection limit, you'll say, okay, then there will be no organofluorine. At that level, there can't be any PFAS at that level. And bear in mind, there are several ways that manufacturers will not know whether they have unintended PFAS present or not. They probably know if they're intentionally putting it in there. But if they're unintentionally getting in there from some chemical that they added as a dispersant, but they didn't read the label or it wasn't told to them that it's PFAS, or if it is a contamination from a container, which was being shown it could happen, though it's not the most likely source, I would say. Or there may be somebody developing a new insecticide that has got PFAS in it that nobody knows about. So these are areas where you'd like to stay alert as a regulatory agency or as a monitoring agency and measure that. And if there is no PFAS, if there's no fluorine, then there'll be no PFAS in that mixture. If you go ahead and do get a fluorine signature, then a smaller subset of those that do have some fluorine in them, you want to see whether it is a fluorinated pesticide that shows up or whether that is something that is a well-known PFAS. And for that, EPA draft method 1633 will work. It's a very complete and rather time-consuming and expensive test, but it will give you a measure of how much PFOS, PFOA, and all the other ones that we can, that works on, I think there are 40 compounds that it measures simultaneously, and that will cover most of the known PFAS that we know health effects from. And there are several commercial laboratories that offer this method now. So at that point, that's my quick summary on what PFAS are and how to measure them, and I will leave lots of time for questions if people have them. My email address is included here in case there's any questions that don't get answered in the next 10-12 minutes. Thank you.
Yes, thank you, Dr. Peasley. Amazing work that you're doing. So we do have some questions that have come in, and I'll read them out for us. This first one, there was a recent study by Lassie. It was targeted analysis and total oxidizable precursor assay of several insecticides for PFAS. And the paper's gotten a lot of attention. It tested 10 pesticides that are used on USDA fields and found 6 of them with substantial PFAS, ranging from 4 million PPT to 19 million PPT. And some of these, like imidacloprid and malathion, are widely used. What are you taking away from that study?
Thank you, Greg, and I thank everybody for listening to my pre-recorded pitch, but being that I'm abroad, they were afraid I wouldn't be able to communicate for so long, so I'm glad to be here to answer questions. And this one I knew about, so I prepared a slide for this one. The others, I'll wing it. This is a study that just came out after I wrote the talk, as it turns out. It's a recent study from Jen Guelfo's group in Texas Tech. It's a great group. They know what they're doing. And they have access to a bunch of pesticides. They put them on fields and they measured several things. They measured using an LC mass spec that we talked about, they measured the standard number of 20 to 30 PFAS that they could measure readily with a known method. It isn't an EPA approved method, it's a modified method, but it is a good method. They have proof that they measured them and that they have internal standards that they measure. And they found ppm levels, very high levels in this insecticide concentrate. It was a concentrate they were measuring it in, but they're getting 1 million times higher than drinking water limits or the observations in the environment. So even if you dilute it 1,000-fold, you'd still be 1,000 times more concentrated than what's present or likely to be in the environment. So these are significant amounts of PFAS, and the predominant one was PFOS. It's a C8 sulfonate, and that gives us a signature as to where it might be coming from that we can tell apart from other signatures. The total fluorine was also measured on a couple of these things. They found one that had suspicion of fluorine, but they didn't see any of the ones in the library. And being a good scientist, Jen knew to go and try this total fluorine method. She did it a different way. She used a total oxidizable precursor assay. And sure enough, that one that was empty showed up with a lot of PFAS. That this is a test that looked for the total fluorine, and those are PFAS that are being discovered there. It's about 3 times higher than the one that before you do the total fluorine. So that means that there's probably 2/3 we're missing out of the fluorinated studies when you do the level. But when you're in part per million, it doesn't really matter whether you miss a factor of 2 or 3. It's still a lot. The most important thing I found from this article is that they actually tested the fields where this was all 10 pesticides were used on cotton crops, which is not a foodstuff, but they grew on these fields plants afterwards. It's an agricultural school. Texas Tech is ag. So they had these fields where they were rotating crops, and they did cotton one season and food another. And they measured in the soil and the crop uptake PFAS, and they report that in the paper as well. And so that's pretty startling that if we use the insecticide, these forever chemicals last for a season and show up next season's crops, even if they are foodstuffs or not in cotton's case. And so I think this is a good warning shot. It shows a couple of very interesting things. These are available in the US and being used in the US field. And this is a USDA facility that they tested these things on. I think one of the takeaways for this talk will be that how do I know whether it's intentional or not intentional? That's one of the later questions I saw, Greg. So I'll start with that one. The amount. If there are part per trillion in your product, it's not doing anything for your product. You need to have part per millions or hundreds of parts per million to really make a difference. So if you want to see surfactancy, if you want to see some sort of solubility, it's got to be there in a pretty appreciable amount, often at percent level, but often at hundreds of parts per million. And once you get below 100 parts per million, it's probably not doing a lot for your product. So if you intentionally want to use it as that, and there's a wide range of uses, but generally you need it to be enough to be worth it. They're expensive chemicals, so you don't add them in for free just because you've got them. But they could be unintentionally added, which means you added another product for a dispersant or something, a solubilizer or a stabilizer, and these things crept in because you add a few percent of this compound, but that compound is rich in PFAS. Then you'll end up with several hundred part per million, which is what they seem to be getting in these things. The other question that also popped up, I see in the question and answer, I'm skipping ahead, Greg, but it's in the same article, which will prove it, is the type of PFAS that comes out can identify somewhat where it comes from. PFAS is widely used, but primarily in the flame retardant, the firefighting foams. It is not used in the fluorination of containers. So the fact that this is 1,000 times higher than what we saw in a fluorinated container, and that it was PFAS, which we don't see in fluorinated containers, then it's not coming from the container, at least in this study done in Texas Tech. The study done in Massachusetts, there were not PFAS discovered, but PFOA and all the other short chain, what's called carboxylic acids. And that is a signature of what comes out of packaging. And so it could be they were part per billion levels, not part per million, which is still high, but the company claimed they didn't use it. It was coming from the walls. And that's one possibility. It was. It could be that in their manufacturing process, they also use these things from other reasons. But we have to be aware of that. And the EPA has done a nice study to prove this. And we have just submitted a paper for publication on that too, showing that, it leaches out. So I think those are, it's a long answer, but this was an important paper that came out just after I wrote the paper, after the talk. So I think we wanted to talk about it and say this is a great example of why a state such as Maryland would be interested in testing insecticides for PFAS. And because, they're there, and 6 out of 10 is a pretty high percentage that had a lot of intentional PFAS in that study. Now, we are not Texas, we are not doing cotton, Maryland, as far as I know. But I think that there are commonly used in pesticides that seem to have some of these things in it. And the question would be how to find out.
Okay, thank you. And I hope we can share a link to that paper. I don't know if it's behind a paywall, but if we can share some more information on how to get to that paper, that would be good for the group. So we'll see if we can.
They published it open access, so everybody can get to it, at least this year. Mm-hmm.
Fabulous. Okay, we'd love to share a link to that paper. So we've got some other questions in here. This one with this high incidence of fluorinated pesticides. any impacts from these and how they break down that we should be aware of. And I just want to help here a little bit in saying that when you pointed out just a few minutes ago that PFAS is uptaken into plants, that's a very unique property here. It's different than some of our traditional organochlorine pollutants, for example. I think that's really highly relevant to the risk calculus here for these compounds. Do you agree with that? And any other thoughts on that question?
Yeah, I wasn't even focusing on insecticides a year ago, or I hadn't even thought of it. But this paper that came out saying they're so widely used, and the specific one Leslie just came out is a great fodder for saying that not only is it used, but because of its persistent nature, it's being used on food fields. Even if the crops are rotated through a non-food crop, or you have a cover crop for a year, that pesticide and its residues, the PFAS residues, will often remain. Some of the soluble ones will get in the water stream and disappear. They're all water soluble at some level, but many of them bind to organic compounds. And Chris Higgins at Colorado School of Mine has done a series of studies, 10, 15 years ago now, that showed that various types of leafy vegetables suck these things in preferentially. So there's a definite bioaccumulation. It's much different than many of the organic chemicals we have. It's akin to some of the metals that go up to the leafy vegetables very well, but it's a different property that makes them transport. And Higgins is the real expert on that. But it's shocking that if that's where we're spraying them, that we might be exposing our population to another source of these things. Your accidental drinking water is the widest source. And I noticed a comment in there that's saying that, it's a firefighting foam that's getting everywhere. That's true. Most of our drinking water supplies seem to be coming from these Class B foams that were sprayed everywhere. And that's because they're so soluble, they get in the drinking water and they don't get filtered out by any process that's normally done. So that means they are in our drinking water, and most of our exposure is probably drinking water. But food is a close second in the sense that, if they're in fish and we're eating a lot of fish, we see that. If we have added it as an insecticide, and this was, a year ago, an unknown path, the insecticides were well known, but we didn't know that PFAS might be coming along with them, then I think there is an exposure risk that some of the foodstuffs might be high. And there's an example of a firefighter in Australia who was, they did a survey of 700 firefighters, and they looked at their blood levels, and the average was about twice as high as the non-firefighters. But there's one guy who was off the charts at 1,600 ppb in his blood. And so they went to visit him and ask why. Was he drinking the Kool-Aid? He wasn't. He was actually eating healthy. He was eating 5 organic eggs a day, but they were grown in the backyard where they had grown their own homemade wheat for bread. And the bioaccumulation of the PFAS from the fire training pit into the wheat was eaten by the chicken, and the chickens bioaccumulate preferentially into the egg. And as he's on a high protein diet, he ate 5 eggs a day, and his blood levels got skyrocketed. He was individually singled out, and he had never used the firefighting foam personally, but he was eating it. And so there's a lot of ways these things can get into products. I think the food way is under stressed, but a worrisome one. I think most of our food is safe, but an EPA has a study, or FDA did a study that said, oh, look, the food's safe. But there are a lot of foods we didn't look at yet, and there's a lot of individual field-to-field variations. We know that the cows in Maine and the cows in New Mexico have passed on to their milk, and some dairy farmers are out a lot of money. So I think that this unintentional sources or extra sources are very important, and I think this is a conference, first one I've seen where people are talking about it as widely as we are here.
Great. How about dermal exposure, Graham? I know in fabrics and those firefighters are using materials. Is dermal important here?
It depends who you ask. The one original study in 2012 said, oh, not a problem, but they even admitted in that study that, well, we didn't test every form of it and we didn't look at different conditions. And since that time, there have been 2 publications out this year, and we've got one in process, and somebody else is doing one I know of, that suggests that it isn't negligible. It may only be 1% or 2% that's applied to the skin that gets through, but that's pretty significant if you have a formulation in a cosmetic or things like that. And so those numbers will become more, once we've got more studies done in the next few years, you'll see that dermal absorption will not be 0 anymore. It'll be some number. Does it beat ingestion? Probably not. Probably ingestion wins. But you can imagine in your textiles or in your cosmetics where they aren't essential, that would be one way to reduce. And so I think dermal absorption, especially workers, people occupationally exposed to insecticides, splashing these things around, you shouldn't touch them anyway because insecticides themselves can be dermally absorbed. But it heightens the risk that you've now weakened your immune system by exposing yourself as well. So that's I think it's I don't think it's the primary worry at that moment, but it is a secondary one.
Okay. So we've got time for a few more questions, and
Sure.
there's a couple techie method questions here asking how many spectra do we have in the PFAS library when we're running mass spec, and then another one related to methods about comparability between 1633 and 537. Are the detection limits similar?
Yep. Excellent questions. And somebody knows what they're talking about in both of them. The methods, the drinking water methods have between 27 and 32, I think, standards associated with them. Of course, there are two standards for each. One is mass labeled and one isn't, but those are technical details. But the library standards are about 30 of them. The 1633 has got 40. Not all of them isotope labeled, but most of them isotope labeled. And so that means that you have 40 of which you can check against a standard. There exists in a company in Canada that makes all these standards. There exist about, I think, 70 or 80, maybe even a little bit more now. But we've got 12,000 compounds out there, so we only have a small fraction of what's there, and they're blessedly expensive. So operating one of these instruments with all these standards starts to be a pretty exorbitant expense to get these label standards out. So yes, they're standards. They're very precise. If you switch between methods, between that, the reason you'd like to is that insecticides are kind of a mess. They're a mixture of things that aren't drinking water. Drinking water is about the easiest to use. And so those methods came out first. This one is the first, sediment is a pretty nasty method. And so this one works on sediment. It's designed to work on sludge. It's designed to work on biota. So if you take fish tissue, it's supposed to work on it. And that means it's testing for interferences that come from the fish. It tests for how extraction methods, and they report a recovery of between 70 and 130% of all the standards when they use them. So that's what the standard is. The detection limits are very comparable, a little higher in the 1633 because of the matrices defects, but they are all in part per trillion levels, and sometimes less than part per trillion in the drinking water, certainly. So I think that those are impressive feats. The 1633, in my opinion, is a method made by committee. It's got so many steps to it that it's very difficult to do correctly. So there are only a few commercial labs that do that one well, and I would get a really good commercial lab to do that test. But it's definitive. If you can run that and you don't see any PFAS, you probably don't have any there.
Okay, and we have part per trillion detection capability. Do you think we'll get to part per quadrillion if we wanted to match up with those EPA health standards?
That's a good question, Greg. Those health standards are based on a lifetime exposure risk of drinking water at this level. So you don't have to get to that level. That risk is a precautionary principle saying if you drink water and you drink a certain amount per day, we all should, this is what you're being exposed to in the water. And that's based on, I think, a pancreatic cell line response, so cancer cells and pancreatic cancer cell line. So we know that any level, that level will cause a bad effect, adverse health effect. So they're set correctly, but it's not what we would, it's based on a health effect. If we are going to look for a different source of exposure through, pesticides that are diluted, then sprayed on crops, and then bioaccumulated in a different crop, it's going to have a different, it's going to be a different number that we should be comparing. I mean, I've got 5 parts per billion in my blood, so do you, maybe higher. And that's one of the things that we need to, don't drink blood, but more importantly, where is that coming from and what the sources are? And I think that the best we can do as a society is try to flag the big intentional uses and reduce them, and then define what essential use is. Maybe some pesticides are essential. Rarely. There are a couple of essential uses I think of PFAS, but there's about 200 that I can think of are non-essential. And I'm hoping that all the insecticides are non-essential uses, and that there are, green chemistry alternatives that will do that surfactant role in these compounds.
Okay, great. So another one here from Chris Victoria that's relevant to our Chesapeake Bay living resources concerns, and it's asking, what are our thoughts on ecological risk? Where do we have studies that help us with the stress and stress responses for aquatic organisms?
Yep, it's a great question. And I work with a biologist. We've just published a paper on maternal offloading on salmonoids, the Great Lakes salmon. They offload the PFAS to the eggs. And ecologically, we don't eat a lot of salmon eggs, but ecologically, the rest of the environment does. And so once these things get into the biota and into the sediment of the Chesapeake, for example, they will impact populations, absolutely. There are a few known examples of populations being affected. There are dozens yet to be studied. And what you need to know is a source of them. We see on individual streams and things like that, we see an effect. There's a stream in Illinois, I know, that has reduced the populations of certain microorganisms downstream from a spill and upstream from a spill and things like that. So I think those will be coming to light. We don't understand the biomagnification factors through all the biota yet, but we know that they exist. And it's weird. Some of them don't seem to bioaccumulate, some do. But that's one of the mysteries of these types of chemicals. There are several that are toxic and known toxic. There are several unknown toxicity. It doesn't mean they aren't. And then there's several that bioaccumulate and several that don't. They all persist. And according to Philip Grandjean, they all seem to have an immune suppression effect. That's, some with more effectiveness than others. So they all seem to have some health hazards. But the way I'd like to say it is I've never met a good PFAS in my blood, but it doesn't mean that we know the effects. And it's just concentration effects. Some have higher concentrations that have the same effect. But distressingly, a lot of these seem to have similar biological effects. And those biological effects, we are worried about humans mostly. But yes, the eco impact of these things is think of it worldwide. How many tons of this stuff are in the ocean or in the bays or in the Chesapeake? You've got a huge impact.
Yeah, really. And our understanding is that these PFAS are protein specific. They accumulate in organisms following a pattern of specific proteins that they're attracted to, as opposed to fats, which we think of from some of those organochlorines. Is that your understanding as well?
Yep, not a biologist, but that's exactly my understanding. They attach in human blood to something called a fatty acid binding protein, and that's different. It gets through the bloodstream and then individual organs, and that's why it takes so long in the body. In a human exposure rate, our shedding of PFAS from our blood takes years. Half-life of PFOS is about 4.5 years, and PFHXS is about 5.5 years. And that's a long time for a chemical that we ingest somehow. And strangely enough, in a mouse and a rat model, those are measured in terms of weeks. So mice and humans aren't alike when it comes to PFAS absorption. And it doesn't follow the fish fat tissue. It follows more the fish flesh, or the fish blood, actually, is what it follows mostly in our studies on fish so far. And so we don't know all that it binds to and why it would transport some and why some bioaccumulate and some don't. But that's true. And stay tuned. There's a lot of very good biologists and ecologists looking at this sort of effect and trying to find it.
Okay. Well, you can bet we will stay tuned. So we have about 2 more minutes or so here. And here's one that's kind of quick. What about Teflon? Are all of our nonstick pans loading us up with PFAS?
Unfortunately, yes, though there's certainly Teflon manufacturers that will disagree with me in that they do nothing but the safe kind. Polymeric Teflon, of course, is quite safe biologically. You could swallow a roll of Teflon tape and it would pass through you with no ill effect or no obvious ill effect, let's say. But the manufacture of it was these Teflon materials, these polyfluorinated polymers, are made with monomer units, but also are floated on surfactants that are PFAS in their own right. And they switched from PFOA being commercially used to something shorter, PFBS, for example, a C4. And they have to, of course, use 10 times more of it than the PFOA. So it's there 10 times more, and it's more soluble. And everybody said, well, the C4 is safe, of course. That only lives in your body for weeks. And it's true. One of the reasons it lives in your body for weeks is you don't just excrete it normally, you actually exhale it through your lung. And if it's, in that sense, much less time in your body, it must be safer, is what the industry claimed. Then, of course, we had this natural, worldwide pandemic, global respiratory virus. Oops, somebody studied COVID, Granjin, and he noticed that there was a negative correlation with PFAS, not PFAS levels, but only C4, the PFBS and PFBA levels. And the higher those were in your blood, the worse outcomes you had for COVID. So, it's just that we haven't studied everything. We don't know where it goes. And the PFAS in polymers are hidden because the polymer itself is probably safe, but what comes out of the polymer is what worries me. And so I've taken aim at those things, and we'll see what the studies show in the future, but I'm worried about polymers. But as plastic pollution in the ocean is microplastics are a big concern and things like that, but that's not PFAS specific, that's all plastics. Mm-hmm. And I'll just end on the fact that my email is at the end of the talk there at gpeasley@nd.edu. I will try to answer all the Q&As that I didn't get to just online here for the next couple of minutes. And then if anybody has questions, they're welcome to send them.
Okay, fantastic. Well, thank you again, Graham, for joining us.
Thank you for the opportunity.
I think you've really helped us understand that there is likely a signal of PFAS coming through pesticide application. So that was very, very helpful to us today.
Hello again. Wow, that was a tremendous presentation. Thank you, Graham. We've learned so much. And next, I have the pleasure of introducing our panelists from the research working group. Of course, it's going to be Dr. Greg Allen and Dr. Vicki Blazer. And for those of you who are not as familiar with Dr. Blazer's work, Dr. Blazer is a research scientist with the U.S. Geological Survey's National Fish Health Research and Laboratory at Leetown Science Center in Kearneysville, West Virginia. With a career that includes teaching and conducting research in fish tissue, fish pathology, and fish nutrition, she continues to work with graduate students at West Virginia University, Hood College, and Penn State, and teaching classes through the Fish and Wildlife Services National Conservation Training Center. Her current research interests involve understanding fish health and its relationship to ecosystem health, environmental contaminants, pathogens, parasites, and land use, and the sources, pathways, and effects of endocrine disruptors and other contaminants of emerging concern. Dr. Blazer received her BS in marine biology and a PhD from Rhode Island University and completed a postdoc at the Veterinary College at the University of Georgia. So I'll turn it over to Dr. Blazer and Dr. Allen now.
Okay, thanks, Bonnie. And I'm going to get us started here by just saying a few more words about the report that we are finishing up. Our research and data gaps work group decided that one of our roles is to capture current and valid research findings and communicate them in various ways, and including to our other work groups that we have in the project, so that we're all staying up on some of the latest information. So we're going to give you some key findings, identified data gaps, and a few thoughts on future direction.
Okay, I'm going to take over for the key findings. As Greg said, this report, we did focus on literature that focused on the Chesapeake Bay watershed, but obviously we looked through literature, globally as well, concerning pesticides. One of the key findings here in the Chesapeake has been that while pesticide use in recent years has decreased, in mass, or the pounds used or applied, toxicity has increased. And this is particularly true for some of the lower trophic level groups, such as insects and crustaceans. The other thing that's probably true all over is that pesticides are always found in mixtures. And the graph here just shows 3 different herbicides, and this was actually monitoring done at Antietam Creek. And what you see is that often all 3 of those are peaking at high levels when one of them peaks. It's often combinations. Next slide, please. So multiple studies point to the importance of mixtures and the effects, the ecosystem's effects of those mixtures. Some of the important things are that when those lower trophic level organisms are harmed, ecosystem impacts can carry all the way up the chain. Degradation and nutrient cycling mechanisms can be disrupted by numerous pesticides. And then, as we've heard about PFAS, some of the non-lethal effects, such as immunomodulation and endocrine disruption, are observed in animals exposed to pesticides. Next slide. The other thing, as we've heard about in terms of PFAS, is pesticides also can be uptaken and travel through organisms to various tissues. And they often end up in, for instance, the flesh that's used for food, but also parts of organisms that might be used for medicines, and serums or plasma that might be used both in medicine and in research. Some of the good news is that there is evidence that some best management practices do work for reducing exposure to pesticides and estrogenic compounds. Next slide. And then we've all heard a lot about PFAS, and this sort of gets us into key findings as well as data gaps. We certainly have evidence here in the Chesapeake that we are finding PFAS in surface water, in fish and other organisms. So we know they're there, but there are a lot of questions yet as to where they're coming from, and also certainly effects. Next slide, please. So as far as data gaps, some of the things we need better documentation and monitoring to really understand temporal changes in pesticide occurrence and exposure. This is the same slide I previously showed, and I put it up because it really illustrates the difference both monthly and annually when we monitor for some of these things. So for instance, in 2014 and 2016, you can see some really high peaks, a little less high in 2015. And then in 2017 and 18, lower, and then a little higher in 2019. So a lot of variation. And we need to understand how this is influenced by things like best management practices, land use practices, as well as climatic factors that might be regulating the occurrence and exposure. The other thing that's key in this is understanding exposures during key developmental times and sensitive periods in an organism's life. So for instance, many of these peaks are in the spring, when eggs of fish and amphibians might be present, or when young of the year that are going through early development. And we know that those are very key sensitive times. So it's important. We need more information on those exposures. Next slide. And then the effects of exposures to complex mixtures. We've heard about all the PFAS, that the different compounds that are present, and it's the same with pesticides. There's lots of mixtures. And then it's not only the parent compound, but also the degradates. And we have very little information about what the effects are of some of these degradates and how they interact with other chemical contaminants, And then as, again, effects of ingredients other than the parent compounds that might be present. So again, the graph here is information from Antietam Creek. The first one on the top, what we're seeing is that most of the time we're seeing much higher concentrations of one of the degradates of atrazine than the parent compound. And then the lower is the concentrations are less, but again, certainly some are high and they vary over time. So we need really to understand, are there synergistic effects, antagonistic effects, additive effects? You know, how are these affecting organisms from lower trophic levels up to fish and ultimately humans? Next slide. And then the other concern is species sensitivity, and that leads into ecosystem level effects. Most laboratory exposures are conducted with model species that may or may not have similar sensitivities as both economically important populations and also as some of the key food web species. And that basically, when you look in the literature, you tend to see a lot of contradictory studies. And one of the reasons is that using different species, you get different results. Using different life stages, you get different results. And so we really need an understanding of that, and then a better understanding of the food web effects and how things at the lower end of the food web affect those of us at the higher end of the food web. Next slide. And I think Greg is going to cover this part.
Yes, thank you, Vicki. So Vicki just described some of the top messages in this draft report. We were using a 10-year time frame. Not sure if I mentioned that before, but we were looking for peer-reviewed articles over the last 10 years to derive some of these recent findings and some data gaps. But here we're providing some thoughts about future direction for the research and data gaps work group. And three here just to mention. First, staying current on methods that are developed to assess risk from multiple contaminants. And this is for pesticides and their degradates. It could also, of course, be used for other contaminants should we get to a place where we have a method. And so we plan to discuss and contemplate a next report that would be something of a roundup on what do we know about methods for this concern. And I've got a link here for a study that was something of a meta study looking across all sources of journal article and other literature. And it's really an impressive summary of where things stand. It's an example of one source of information that we might use to, again, give us a snapshot of where we stand with this. This is a very long-running issue and challenge, but there is work that's being done. I've recently seen some grant programs that are giving out money for projects that are designed to help move us forward with this challenge. And this is from Organization for Economic and Community Development, I believe, in partnership with the United Nations. So it's a really worldwide synthesis on where things stand with methods for assessing risk from multiple contaminants. And we know that in our surface waters in Chesapeake Bay, there is always some combination of things present. And our standards, our risk criteria that we have for some of our contaminants of concern are all based on that individual contaminant. But when we think that there might be synergistic effects from a cocktail, as some researchers refer to it, a cocktail of contaminants, then the question is, are those single contaminant risk criteria still protective in light of there maybe being some synergistic effects? So those are some of the challenges around this that have been ongoing for a very long time. And we may decide our next report will be some sort of synthesis on where the state of the science is. Next, as we have already talked about, and we, I guess, made a promise to Dr. Peasley, we want to keep up on all the latest science with regard to PFAS and pesticides. That's important for the environment, for the living resources of the Bay. It's also important for our farmers and for healthy farms and healthy soils. So this is something that we will certainly be keeping up on, and we'll see how our work group can help to pull together summaries on this topic and keep us all informed. And then last here, I mentioned that last year we did a large-scale Jamboard, and we're working through the feedback that we got. And it's very possible that our work group will have some suggestions coming out of all of that input that might give us good ideas for future work. And get the emphasis here on trends. I think our research work group can also help keep up on what do we know about trends. And that's trends in concentrations of pesticides in surface waters, in fish, in other living resources. Trending is its own science that can be challenging because you have to have enough data to really be able to make a statement about a trend. But it's so important to us all to know which direction we're headed, that I think that's another place that our work group will be thinking about adding value to this community. So those are a few future directions for us. And that's most of the comments that we had for this report and some of the future work for this particular work group.
Wonderful. Thank you so much, Dr. Blazer and Greg. And we are really excited. The work group has been putting a lot of great materials together to look at for research. We've actually added a bunch of studies, which is partly why we've delayed publication. So we'll be looking forward to getting that out the door. We have some questions for you guys. One is, what sort of BMPs were documented to improve contaminant levels in water?
Yeah, well, let me start, and then I'll give it over to Vicky. Yeah, so among the universe of best management practices, and particularly those that we track in the Chesapeake Bay Program Partnership, mostly for the purpose of nitrogen, phosphorus, and sediment reduction. But among that universe of BMPs, we don't have a whole lot of data about effectiveness for the contaminants of concern, most of which are organic chemicals, meaning they have carbon in them somewhere. We don't have nearly the amount of data that we'd like to have, but we make some assumptions. And one that comes to mind is that wherever a BMP is highly effective at trapping sediment, it probably gives us a benefit on a range of organic contaminants because they tend to be sticky to sediment. Carbon to carbon sort of attraction there. And so wherever we capture sediment, we're probably doing something good for the loading of toxic contaminants, and also for the contaminants that are in rainwater that get dissolved or get mobilized in stormwater. Wherever we have a BMP that allows that stormwater to infiltrate, to settle, to have time to be biologically treated in the soil zone, things like green stormwater practices, green ponds, and rainwater capture devices that allow that surface water to percolate, that is also helpful. So we end up having to apply some of those broad assumptions for the most part because we don't have a lot of data. Now, one that I will mention that we have some data on that's not pesticide specific, but I think we had this presentation at this conference a few years ago, manure injection. So there's a BMP that instead of applying manure broadly to the field, if we use the injector technology and get it down into the soil zone, we see that there's a lot less runoff of things like hormones that are in that manure. So that would be an example where we have some specific data.
Great, thank you.
And so, Vicky, do you have anything to add to that?
No, I agree. I think a lot of the BMPs like riparian zones and things like that cut down on runoff from fields into streams and rivers help a lot. Also, I guess we should mention some things like cover crops. If you're then killing those cover crops with herbicides, that's sort of a negative. So that's why we say some BMPs. So just something to think about.
Good, okay. We have another question. Why are degradates important?
I'll take that one if you want, Greg.
Yes, Vicky.
At least from the aspect of fish health, there are some papers out there that have shown that some of those degradates are just as toxic and in some cases more toxic than the parent compound. And so one of the issues is that we're often not measuring the degradates. We're only measuring the parent compound. And in that study we did from 2013 through 2019, we only started measuring the degradates in 2018. And you know, the data that I showed is we're seeing often higher levels of the degradates than we are of the parent compound. So what we really need to know is which of those degradates have adverse effects on various organisms.
Okay, thank you. We have another question. What is the practical application if we have a method that would assess risk for multiple contaminants?
Yeah, I think that's a great one and a challenging one, but I guess if we were to get to the point where we had a valid method, it could be used in predictive tools. So it's conceivable that we could use information like land use and monitoring data, actual monitoring data, maybe other information, some combination of those things to say, given what we now know about risk from mixtures, we are likely to see in a given area a higher risk to living resources than in others. So ideally, we could roll it into some form of a predictive tool that would then allow managers to go apply management practices in those areas to reduce risk. So that's a little bit of a visionary outcome. But I think the question of if we did get to the point where we could put a number of detected contaminants, maybe even some of those degradates that Vicky just said maintain some toxicity, into some sort of risk analysis tool that we can then use it in a way that actually helps us with management actions and decisions. And we'll just have to see. Right now, we have some of those kinds of predictive tools, but they are not really considering synergies and lots of contaminants being present. So we'll see if we can get to that point.
Okay, thank you. Just wondering if there is, any pesticide monitoring that's going on in the Bay waters that you all are aware of, and if so, is it enough?
Well, I'll throw a few things that I'm aware of and see maybe Vicky has something to add. With regard to toxic contaminants in the Chesapeake Bay watershed, we don't have nearly the amount of data that we'd like. A lot of the resource goes to monitoring for impacts of nutrients and sediments. One of the very few long-term data sets that I'm aware of for pesticides comes through USGS and their river input monitoring stations, RIM stations. And so these are located in some of the highest flow rivers to Chesapeake Bay. And for quite a long time now, there's been a standard set of pesticides that have been analyzed at those RIM stations. That's a good example of that future direction that we just mentioned of looking at trends. I would guess that that's one of our highest potential data sets to use for trends. We really should get in touch with that data and see if it's useful in that way. Other than that, I don't know of much long-term monitoring. It tends to happen, excuse me, more in a snapshot sort of basis, in federal studies, maybe some state monitoring, and maybe some academic work. And in those areas, we do get some snapshot monitoring, but they tend to not be long-term. Does that match up with your understanding, Vicky?
Yeah, I would agree.
Okay, great. Thank you. Well, it sounds like we have a lot of important work to do ahead, and this report will really help define some of those data gap areas, and it's going to be very exciting to see that. It looks like we have 2 more minutes, and there's a question here. Has correlation of land application of sewage treatment plant biosolids and pesticide contamination levels been studied?
Yeah, not to my knowledge, but that doesn't mean that there isn't some data and some papers out there. I will say that biosolids seems to be coming back on the radar brightly again, because we have some recent data that shows that PCBs and PFAS are partitioning over to solids in our wastewater treatment plants. And in a lot of cases, we end up with land application of those biosolids. And that is some just very recent data showing that there is a fairly strong signal and amount of PCBs and PFAS in those biosolids. Whether it also includes pesticides, I'm not aware of data, but not really certain of the answer there.
Can I add to that, Greg?
Sure.
No, you're absolutely right. There's a strong correlation between biosolids and PFAS. I am not aware of anybody doing insecticides at the same time, but the PFAS definitely correlate with biosolids. And in many states, Maine and Alabama and a whole bunch of ones, there have been big studies on that. It's good.
Yeah, yeah. And some tragic outcomes. I think you mentioned dairy cattle that have had to be slaughtered as a result of being so contaminated that they were not able to provide any product anymore. So we know that biosolids that are land applied on farm fields can have some really dramatic impact.
Right, thank you. Well, I think we're about out of time, and if there are any other questions in the Q&A that Dr. Blazer and Dr. Allen can address, then we'll go ahead and have them fill that out. And I'm going to turn things back over to you, Greg.
All right.
Thank you both so much.
Yeah, thank you, Bonnie. All right, so next we are going to hear from Kristen Harbison. And Kristen is political director for the Maryland League of Conservation Voters. In her role, Kristen heads a number of state policy-related projects, including leading the Citizens Campaign for the Environment, which is a large coalition of Maryland's environmental community who work on policy. Also, there is the annual environmental report card that rates legislator and administrator performance. Kristen joined Maryland's League of Conservation Voters in 2015 after 5 years as senior staff to Chairman Maggie McIntosh, where she worked for the Environmental Matters Committee. Kristen holds a master's degree in history and museum studies, but her lifelong passion for politics and policy led her to shift to advocacy work. So welcome, Kristen.
Thank you very much. I'm delighted to be here. I'm also on the board of the Maryland Pesticide Education Network and have been happily on that board for the last 5 years, I think. Anyway, so thank you all. I'm delighted to be here. For those of you who are not familiar with Maryland League Conservation Voters, we are a statewide environmental organization that calls herself the political voice for the environment. We work for a healthy environment for everyone in Maryland and work to pass strong environmental legislation. We hold our legislators accountable through our scorecard. And then we also have the opportunity, because we are both a 501c3 and a 501c4, to actually work in politics to help get our champions reelected and to work to support candidates. So I will tell you a little bit about sort of where we stand. I think a lot of this, if you've been paying attention to news, will be new. But just as a sense of sort of where we stand after the election. Next slide, please. So to start with, in the Senate, so we have about 17% of the Senate will be new. We have, including Chairman Kelly, who is leaving the chair of Finance Committee, one of 4 Senate committees. Next slide, please. They will be those 8 members will be replaced by mostly relatively familiar faces to the General Assembly. We have delegates Brooks, McKay, Moutz, and Young will be moving to the Senate. We have former delegate Folden will be returning to the General Assembly after 4-year absence in the Senate. Anthony Muse is a former senator who will be returning to the Senate after, again, a period of 4 years absence. Mary Delaney James is a former delegate who will be returning to the General Assembly after 8 years absence. I believe 8 years absence in the Senate, to the Senate. Interestingly, her father she is the daughter of a former Senate president, after whom the Senate office, one of the Senate office buildings is named. The new face to the Senate is Dawn Guile, who won in District 33. She's never held elected office before, but is, I think, going to be a very exciting and powerful new voice in the General Assembly. Next slide, please. So what this means in the Senate committee that we care most about is we know that there will be at least 2 new members. And I will say from here on in, there's a lot that is unknown. We do not know all the new faces that will be in the General Assembly, because we don't know whether anybody will be moving to appointments or whether there will be shifts within the committees. That often happens at the end of a term. They look at the Senate makeup, and people move from committee to committee. But what we know is that the Environmental Health and Education, Health and Environmental Affairs Committee, which is where most of the environmental regulations that that relate to pesticides in the Bay go through. So there will be at least two new faces in that committee. Next slide, please. So generally speaking, what we know is that, again, there's not a lot of new faces in general, but there'll be some shifting from the House to the Senate. And also what relatively pretty well reported is that the Senate Democrats picked up 2 seats. This is one of those places where in the overall national expectation was that Democrats would do very badly this election. They did not, even on a national level, but we see in Maryland that Democrats actually gained seats, which is important, which is an important trend. We know that there will be one new leadership post. There may be others. As we're looking at the statewide office, there's often in General Assembly, after the change of a governor, they find people from the General Assembly to take leadership positions in the administration. And we've already started seeing that from one of the House changes. But we'll get to that in a second. The other thing that sometimes happens in the General Assembly at the end of a term is that there can be restructuring not only of membership within the committees, but they sometimes change what committees deal with which jurisdictions. So there might be shift even in terms of what committees deal with which subject matters. There's been a lot of talk. We don't know much, but we're all waiting with bated breath, and we should know more in the next couple of weeks as some things get finalized and we get more information from our new incoming administration. Next slide, please. So in the House, we have a lot of people leaving. Almost 30% of the House, it will be new. Interestingly, this is a big number, but it's not an uncommon number. I looked it up. This is exactly the same transition from the last election. There was 28% of the House was new in the last term as this term. This does not count for, however, any House members that move from their position to the administration. Next slide, please. In a few of the interesting places, people to talk to from that very large list, there were 5 seats that changed parties. The Democrats picked up, grabbed 5 new seats. They grabbed seats in Western Maryland, the Hagerstown seat. They gained a seat in Baltimore County in District 8. They gained 2 seats in Howard County in District 9. And then in District 33, which is a traditionally very conservative part of Anne Arundel County, they gained another seat. They only netted, however, 4 new seats because through redistricting, the Republicans picked up a seat in Baltimore County. Next slide, please. Oh, and I realized the last slide was wrong. The Stonko delegate should have been red. Delegate Stonko is a Republican. So in the committee that deals with most of the environment and the Bay, pesticide in the Bay, there's almost a quarter of the membership will be new. And again, we don't know what other changes might happen as people move from one committee to another, or if there's reassignment or any members that might go to the administration. But we know that there will be at least a quarter of the delegate of the committee will be new, and 2 subcommittee chairs will be new. Notably for the issues related to this subject, we're looking at a new subcommittee chair for the Agriculture and Natural Resources Committee, as Delegate Jim Gilchrist from Montgomery County is retiring. That is a very important position for pesticide and for pesticide legislation, because the pesticide legislation tends to go through the Agriculture and Natural Resources Committee. So it'll be interesting to see who gets assigned to pick up that subcommittee chair. And then again, what the other makeup will be of the rest of the committee. Next slide, please. So again, just as a recap, this is a lot of change. There will be more, but there's nothing unprecedented about this amount of change. Interestingly, unlike the Senate, there were sitting delegates who lost either through redistricting in the General Assembly, in the primary, or in the general election. There are 4 important leadership changes in the Senate, in the House. 2 new committee chairs. Delegate McIntosh, my former boss, is the very powerful chair of the Appropriations Committee. Shane Pendergrass has been the chair of the Health and Government Operations Committee. Both of those new committees have new chairs. Delegate Talmadge Branch has been the minority whip, which is a very powerful leadership position in the House, and he retired. Delegate Eric Lutke is the first member of the General Assembly to get picked up by the next gubernatorial administration for that post there. He will be the new chief legislative officer. Eric Lutke is the current majority leader for the House. So there's a lot of leadership changes in the General Assembly, which will be interesting to see how that tracks. Next slide, please. So going into the statewide office, obviously this is the first time in 75 years where all of our constitutional statewide offices will be brand new. We have, in addition to the governor, lieutenant governor, comptroller, and attorney general, the state treasurer, which is a statewide official, will only have been in his position for a year. So it's a very new team of leaders at the state level. And also, interestingly, and of course this has been widely reported, this is the first time that Maryland has elected either a person of color to governor or lieutenant governor, governor or attorney general, or a woman to statewide office. So this is all the 4 of our statewide leaders. And Lieutenant Governor-elect Bruna Miller is an immigrant, which is also path-breaking. So all 4 of these leaders are history-making in their own way. Next slide, please. A few things that we can expect from the Moore-Miller administration. He has been very open about, very aggressive in pushing about the idea of a chief sustainability mitigation and resilience officer who will be important to coordinating all of the agencies to climate resilience and mitigation. He's been very open about support for the Bay, for supporting sustainable conservation practices. He's spoken very widely about holding other states accountable and working in partnership with other states. We're protecting most vulnerable communities. He's also spoken. We can also, I think, expect him to have a more open view towards pesticide regulating pesticides than maybe our current governor has, including, and as well as pesticides, also PFAS. Next slide, please. The other important statewide office, obviously, is the Attorney General. Attorney General Frosch has been a leader and a hero for a lot of the pesticide legislation. And I think that we can expect Attorney General Brown to continue many of those same trends. He's been very open about wanting data transparency, relooking at the relationship with the assistant attorney generals to the attorney general's office, and continuing the attorney general's Frosch's efforts to using the Maryland Defense Act, which has allowed some enforcement support. And will be looking, I think, for more additional enforcement authority. Next slide, please. So generally speaking, for generally election takeaways, the environment was a really important issue to voters in Maryland this year. It probably wasn't the top issue, but it was important. The candidates that gained seats in the Senate, and in the House, where there were party changes, many of those candidates actually ran on the environment as one of their key tenets. So that was an important part of their victory. At all levels, people are talking about equity, environmental, and economic justice. So we can see a lot of effort from our statewide officials, as well as our new elected leaders in the General Assembly, to be pushing those issues and pushing that level. One of the interesting opportunities is for Maryland, actually has to do with our neighbor to the north of Pennsylvania, where in addition to having a governor who has been their attorney general and has been important in holding polluters accountable in Pennsylvania, they have a state house now, which is more open to possibly regulations for the Bay as possible. So I don't know what's going to be possible with that, but there are opportunities for maybe additional partnership with Pennsylvania. And Governor-elect Moore has talked again quite a bit about wanting to work in partnership with other states as well as the federal government. There are a lot of places where we hopefully will be able to make progress in the next 4 years, but there will be different challenges working with this administration and others, and we'll need to continue to remain vigilant and holding all of our elected officials at every level accountable. And so that's what I've got for you today. Next slide. Final slide. So I'm happy to answer any questions that anybody may have.
All right, Kristen, thank you so much. Yeah, so there is at least one question here from Barbara Walsh asking, are there any legislators in Maryland who are leading efforts for testing and regulating PFAS specifically? Yes,
there was legislation passed this past year on PFAS, and there will be additional legislation coming forward this year, including on trying to look at PFAS and pesticides specifically. I'm not sure that we've finalized who necessarily all the sponsors will be in those efforts, although I believe Vice Chair of the Environment Transportation Committee, Dana Stein, has been long a champion of that, as has Delegate Sarah Love, also on that committee. So I expect that there will be legislation on PFAS. There will be more work in that arena coming up, as there's been as we've been seeing, a lot of new information and studies and reports about the presence of PFAS in our waterways, and they'll be looking to do something about it, I think.
Okay, all right. Well, that's encouraging. Also, a number of years ago, there was legislation passed that created a source of funding for voluntary reporting of pesticide use. And I think we've never been certain that materialized quite the way we envisioned. Are you aware of anything that's going to happen related to pesticide use reporting?
Well, in terms of pesticide use reporting, that's part of a bigger challenge having to do with agency enforcement and inspections. The ability for our agencies to do the work that we ask them to do, it has been limited because the agency staff and budgets have been cut significantly. And this has been not a problem of just the last 8 years. This is a much longer trend. However, it has reached a crisis point in the last 8 years. And so I think, and there's been quite a bit of talk amongst the officials that are our new officials, that's got to change. Something has to change, that we need to be able to ensure that the legislation that is passed by the General Assembly is actually able to be implemented appropriately by the agencies, which will require them to have appropriate staffing and funding, especially for inspectors and enforcement. In the approach to by the Hogan administration on enforcement has been compliance assistance as opposed to strictly enforcement, getting away from enforcement as a hammer. And I think that I would hope that we will see more focus on actually implementing and making sure that our laws are upheld, both from our agencies and through the Attorney General.
Okay. Yeah, so a couple more questions here and related to agencies. Here's one. How does a new administration pick leadership for agencies? Are there any we should be looking at?
I mean, I think how the agency heads are selected is not something that's above my pay grade. There are transition teams. There are a lot of very smart people who are working on identifying people who will be best positioned to carry on the agenda of the administration and carry the ball forward for what the governor-elect has said he wants to do. There will be, so yeah, we should be watching all the agencies. We should be watching all the environmental agencies and seeing who is selected for those positions. Again, I think that we can look for transparency, a focus on environmental justice and economic justice, and that will be, I think, and really trying to listen to the communities who are most impacted. There's been a lot of talk about Justice 40, which is the effort to get at least 40% of state resources directed to the most impacted communities. That's something that the governor-elect believes very strongly, and he's been very open about wanting to address the most impacted communities. So that, I think, will be the focus of the agencies. That will be the charge for whoever he selects to be his agency heads. And I see in the question, there's a question about if Chairman Barbe will be continuing as his head of environment and transportation. That is it, as far as anybody knows, that will be continuing. Again, there's so much that we don't know yet, and we won't know for the next few weeks as things are getting shuffled through. But as far as I know, I have not heard anything else that he will be leaving that post for anything. They will not. They don't replace chairs of committees. The chairs of committees would have to leave for other things.
Okay.
As a general rule, I can't remember any place where time. I mean, who knows? There's always, anything is possible. And so watch the space. It'll be really interesting to see.
Yeah. Okay. And one more quick question. Our Chesapeake Bay watershed involves 6 states plus the District of Columbia. Do the other states have a League of Conservation Voters?
Many of them do. We do have a state league in Pennsylvania. There's a very strong state league in Virginia, New York, New Jersey. There is not one in Delaware. And DC is the National League of Conservation Voters is headquartered in DC. So they work with the federal government. But yeah, there are 30 state leagues across the country.
Do you ever come together in ways that are geographically focused, like a Chesapeake watershed?
We talk pretty regularly. I was actually, just before this presentation, I was talking with my counterpart up in Pennsylvania to get a sense of what she knows about, to just get a read on what they're thinking about their new governor, and make sure that what I was thinking about Pennsylvania was accurate to from what she knew. And so yeah, we talk pretty regularly. It's a pretty tight and coordinated group.
All right. Well, that's good to hear. Okay. Well, thanks so much, Kristen. Great information.
Thank you.
Yeah. Thanks for presenting today. Okay. So The next thing we're going to do just for a couple of minutes is to take a look at the Jamboard information that we got from you all, and that's not it. Oh, wow. I'm sorry. Okay, here we go. Here we go. So I'll need screen share again. And I will do that. So here we go. All right. So last year, we asked for feedback on 2 questions. And what I'm going to do is just give you an update on how far we've gotten with using the feedback that we got and some next steps on this. So in question 1, we asked, what are the most important opportunities to reduce risk from pesticides that are used in the watershed? And we got a lot of great responses. And so what we've done is started the affinity work, which is taking a large brainstorm list and starting to put it into categories. And so you can see here on row 3, the categories that we identified: educating the public, scientific information and studies, creating alliances, trees and biodiversity, legislation and enforcement, and then an other category. And so once they were placed into these categories, we then considered, do we have something going now in the project that relates directly to that idea or the suggestion? And so if it's coded in green, it has the background of green, that means that it's one that we do have something going with. Either it's a fairly comprehensive response to that idea, or it's in the same area, and we might consider these comments for how to do it even more effectively. So starting with row 4 here, you see some examples of things like bringing together diverse stakeholders and providing education. Well, we do that across the project. That's a lot of what this conference is about. And we do it within our work groups, where we have things like specific activities around education on things like preferred farming practices. So we've got some of that going. We certainly can and will do more. The next example here show the connection between pesticides and depletion of soils. And that would be very much in line with some of the products that the agricultural work group has produced. A stronger alliance with the Maryland Ornithological Society and the Maryland Native Plant Society. We do have some involvement from them on the Smart on Pesticides Coalition, but we will check back and make sure that they are involved. And so we have a fairly good match already with that suggestion. The next one, develop the use of forest or wetland buffers to reduce runoff in the bay and its tributaries. That one isn't so well attached to our work groups in this project, but it is what the EPA Chesapeake Bay program and the Bay Program Partnership does every day. We know that forest and wetland are critical structures for maintaining water quality. And so we're tracking and incentivizing and doing everything we can in the Bay Program Partnership for forest buffers and wetland buffer. Next one having to do with policy is squarely to our Smart on Pesticides coalition that does some of the legislative advocacy work. And then this last one, use art to help make the cultural shift from the green lawn to less green, and that's a beautiful thing. And so that's an interesting suggestion of using art. We haven't yet tagged that to any particular work group or effort, but it certainly is compelling, and we're going to continue to work with it. So this is the way that we are doing this analysis. You can see that for this question, it goes on for a bit. Lots of great ideas that we're going to continue to contemplate. The second question, what public education topics and management actions should the project promote and advance? And you can see the same structure here. In this case, the categories were education, management enforcement, communication, alternatives, risk, and then other. And so we're doing that same activity of identifying where we have some actions related to that idea, and which of our work groups or other groups would be most appropriate to consider to continue to consider these suggestions. Now, we're going to have a meeting in the first quarter of 2023 that is going to bring together the leads for each of the work groups to spend some time really looking at this, all of us together. And the hope is that it will really inform our work going forward, and that we will be producing products that are useful and informative and following a lot of these great ideas that we got last year. Now, that is not a closed meeting by any stretch. So if you're intrigued by this and energized and want to join us in continuing to work through these ideas and turn them into meaningful work activities, you know how to get in touch with Bonnie and others, and we can make sure that you get the information for that working meeting early 2023, where we're going to look even more closely at all of this information. So I want to thank you for that input from last year, and that is what we're doing with regard to really trying to put it to very good use. And so what we're seeing here now is our three work groups, and we have research and data gaps, and you've heard from us, but also we have agriculture and the healthy alternatives work groups that we're going to hear from today. And we're just going to provide a little bit of time for some of these leaders to let us know what's happening in those work groups. I think we're going to start with Veronica in the Healthy Alternatives group.
Thank you very much. The Healthy Alternatives Work Group educates the public on pesticide impacts to health, pollinators, and the bay, and highlights safer alternatives and choices that we can make. An important project of the working group has been the development and promotion of the saferdisinfectants.org website, which we launched earlier this year. We directly contacted several hundred organizations, including health departments, school systems, public health and health facilities, hospitals, and health-related publications across the country, and we're still at it. This slide shows the website and the social media posts we're using to promote it. The best way to get search engines to notice a website is by getting it linked to other websites. So if your organization can post on social media or link to saferdisinfectants.org as a public service to your audience, it will also help spread the word and increase awareness of this very, very needed tool. Moving on, this work group, our work group noticed the popularity on Jamboard for converting information to more current formats. So this year we converted the Managing Mosquitoes Without Pesticides fact sheet into infographics and created a series of graphical social media posts. People clicked on the post and could view the full infographic on 8.5 by 11 flyer, which they could print as well. So please visit our Healthy Alternatives website for more helpful and shareable resources. And we're looking forward to discussing the Jamboree board ideas further when we meet next. Thank you very much.
Thank you, Veronica. Great to hear that there's some activities that were really informed by the Jamboard last year already. That's really wonderful how you've been responsive to that. Okay, so next we'll hear from the Agriculture Working Group, and that is Errol Maddox.
Hi, the Sustainable Agriculture Working Group educates farmers about pesticide impacts on family farm life, health, the bay, pollinators, and safer alternatives. We've been focusing on a couple of things. In working to update our 20-page farmer toolkit, we've realized that people are turning away from booklets. Instead, we've been developing social media posts that pull key content from our toolkit and convert it into infographics. These will be shared on social media channels. We're also helping work group farmers develop a series of videos aimed at the farming community. We started with Steve Kowalski from Mason's Farm and Mason's Heritage Farm. If you attended our November 3rd session, you saw Steve's very inspiring and pragmatic presentation on how his family farm has transitioned to become Maryland's largest organic grain producer. Steve shares the techniques that they use to build soil health, reduce inputs, and the many benefits they realize using organic regenerative farming techniques. Other work group, family farm groups will do videos on innovations in their farming operations. And looking at the Jamboard ideas from the last conference, our working group was impressed by how many people suggested converting facts into more popular formats to social media. Ideas like infographics, even having an artist do a series of cartoon posts. Video was often mentioned as an important direction to go for educating farmers, consumers, and involving our community in sharing their success stories. So some seeds, no pun intended, took root from last session's Jamboard and are already beginning to sprout in our work group. We're looking forward to going through a more in-depth process with the Jamboard ideas to see what else may be possible. And as a request, suggestion, if you have an interest in our work group, you don't have to be a farmer, just having an interest in how we're growing our food here in Maryland, let Bonnie know and we'll have some fun. Thanks.
Yeah, great. Thank you, Errol. And it's wonderful to see that you're connected with Steve Kraszewski and the work that he's doing on his farm. We heard from him in our previous session, and it's absolutely amazing what he's doing with organic farming at a larger scale than I think we've seen generally. And so great that we're capturing some of that. And yeah, I hope everyone heard Errol recruiting for the Ag Work Group. If you're interested, we get things done when we have people participating and helping out. So we really welcome anyone who's interested to join any of these work groups, and including agriculture. Okay, well, and you've heard from the Data Gaps and Research Work Group about what we're up to. So I think that would get us our briefings from our work groups. And that's bringing us pretty close to our conclusion today. It's amazing how fast a couple hours go when you're talking about really interesting issues of the day and in environmental science. And I think we have just a couple of wrap-up things to do at this point.
Wonderful. Thank you so much, Greg, and to all of our presenters. I just wanted to say that we're going to show you some quick slides about our sponsors who make this conference possible. And they are also great contributors to our community in many ways. So we hope you'll get to know them. And we also want to recognize our generous funder support. If we can have that slide back again, great. These foundations have been supporting the project for many years. They are a huge support to how we've been able to continue for 16 years, and we're very grateful for their continued support. Next. And so we want to leave you with some of our great resources that we have on our websites. You can use the bit.ly links displayed here to find out more about pesticides in the Chesapeake Bay Watershed project and find out about more about the projects that we've done and the past conference presentations, many of which have videos and files linked to those. And we'd really urge you to join a project working group. I'll be sending out some materials next week that will pull together a lot of what we did with this particular conference. And in that, I'm going to include an invitation. So if you all have been interested in this project and would like to join a working group, we'd love to talk to you more about what we're doing. And we also have our main website, mdpestnet.org, which was recently redone this year. So it's a tremendous resource. We have over 500 web pages here with all kinds of databases that pull together studies on different kinds of health impacts of pesticides, resources about alternatives you can use to avoid pesticides, and various other programs that the organization is doing. We also have our goorganicmd.org website, which really helps people make that change in their own lives to live a life that's more pesticide free. And that one contains lots of resources, places that you can get products from that would be pesticide free, all kinds of practices you can incorporate into your life, even if it's on a budget. So check it out if you haven't seen it. And of course, our Safer Disinfectants website, which takes all of the pesticide registered disinfectants that are part of what's available to deal with COVID-19 and sorts those out so that people can look at what their products may be that they're using and determine whether it's one that poses an increased risk or one that may be a safer disinfectant, and find products for any need that they would have. So please visit our websites, link to those, and give us feedback on what you think of them. Next. Greg, would you like to have any last words before we close out?
I sure would. First of all, I want to emphasize a comment in chat from Felipe Arzeas, and that is thanks to Bonnie. Bonnie is incredible, and she's really the one that makes this all come together and makes it happen. So thank you, Bonnie. And thank you everyone who participated today. Hopefully you were at our previous session as well. We really appreciate you attending and asking these great questions. And so I think we've had another good year, and we look forward to seeing you at the 17th annual Pesticides in Chesapeake Waters Conference.
Indeed. Thank you so much, Greg. You know, we have a wonderful team behind the scenes. Emily Ranson and Doug Miller are working the controls behind here. And we also have a team of other people that contribute in various other ways. So we're really grateful for that. And we really want to thank our presenters today. And, you know, you brought some great material to our attention, and we look forward to continuing to work with that. So I'll be sending an email out next week with a lot more conference follow-up materials. We have a survey with a link here, and as soon as we close the window for the conference, a screen will pop up on your computer that should give you a clickable link. And we'd greatly appreciate it if you would use that. It's a very quick survey, but we'd like to hear your input and your ideas about what we might do next year that would be of interest to you. So thank you all so much, and have a great day.